Hello, welcome to another episode of Automation Digest. Today we will be discussing about factory design pattern. Factory design pattern is one of the creational design pattern which provides the interface for creating objects in a superclass but allows the subclass to alter the type of the object that will be created. In other words, it defines an interface for creating the object but lets the subclass alter the type of object that will be instantiated. In simple, we will have an interface for creating an object. We'll have a concrete class which will be implementing this interface. And finally, the code which will instantiate the object and perform the activities. The factory pattern decouples the client code from the actual implementation of classes. Some of the real-time examples of factory pattern can be database connections, getting UI elements for different type of operating systems. Let's understand this in detail. So we have a factory as interface. That would be the factory of the product, which will have the skeleton of methods that we require. Based on this factory, we will have all the concrete classes created. And these concrete classes will have the implementation of this factory methods with respect to the actual required product. For example, if we take database into consideration, the factory of the product will have database connection and the declaration of all the methods which are required in our product for the database. In the concrete class, we will have the implementation of those methods. The DB selection will be done based on our condition. Whichever DB we require, based on that requirement, we will finally be creating the object. Here, the reference variable will be of the interface factory, and the object which will be created would be of the concrete class based on our condition, which means it becomes easier for us to maintain any change that is required in the classes. Also, we have encapsulated the whole structure. Now let's get into our coding, and while doing that, we'll also understand it in depth. So I've already created the class called factory design pattern, which will have our main method and will have the other implementation in different classes and interfaces. Let's say we want to create the factory design pattern for a fruit juice store, where as per the requirement of the client, we are serving the juice of the desired fruit. So here, our factory is a fruit juice. The first thing, the factory has to be an interface. So let's create an interface. In this, let's have a method called juice maker. Let's keep it simple for now. Now, for this factory, we will require the concrete classes. The concrete classes will be the actual fruits that we are going to serve in our store. Let's say the classes can be apple fruit juice, watermelon, and orange. Now, this concrete classes has to implement our interface or the factory, which means they have to implement fruit juice in this case. If you observe the error, that's because we have not defined our juice maker method. Let's define it. Now, let's have a simple print statement to tell which type of fruit juice it is. Let's have the same implementation in the other classes as well. Now we need the client code to make a decision which type of fruit juice we want to create and pass on the object for that class. Before we take the decision, we do not know which type of fruit juice it is going to be. So the return type of the method will be our parent interface, which is fruit juice. So let's create a class named fruit juice counter and a method called take order. Here we have to pass the name of the fruit that we want. We can here use any of the conditions, if else condition or a switch case to take the decision. Let me use switch case. Now in the for condition, we have to create the object and pass it on. For default, let's throw an exception. That's it. We have created the factory successfully. Now we just need to come to this counter, pass on the fruit that we require, and see if we are getting the correct statement. We would now be creating a reference variable of type fruit juice, and we would get the object of the respective concrete class by calling the method takeOrder and passing on the name of the fruit. Now let's execute the code and see the output. There we go. For the first one, for the name apple, we have the output called I am apple fruit juice. Let me correct the statement a bit in the SOuts. Yeah, and let me execute this again. Now if you see the output, for apple, we have apple fruit juice, watermelon, we have watermelon fruit juice, orange says orange fruit juice, and for potato, we have an exception with the message invalid fruit type. Now we can use this for whichever fruit we require. When it comes to automation using Selenium, we can create a factory of all the pages that is required for the application under test. Create a decision maker for the page that we want to go, and from our test method, we would pass on the value of the page and the actions that we want to perform on that page. Some of the advantages of factory design pattern involves reusability of code, enhanced maintainability, centralized control, and of course, encapsulation of object creation. Whereas the disadvantages of factory design pattern would be increased code volume, overhead for the initial design, and most importantly, tightly coupled code with the factory. Based on our requirement, we would select design patterns. If we find the pros required for our design outweighs the cons, we will use that design pattern. Next session, I'll come up with another design pattern for our usage. Till then, stay tuned. Happy coding.